36. So we covered last class, we introduced major global problems right here. We covered smog and acid deposition. And now we are going to cover, let's call it climate change or global warming / whatever. In order to discuss climate change, we got to do a little bit of climate review. So, or not review, because most of you have never seen this. So who could tell me some factors that affect our climate? Solar activity, good. What else? Good job. Volcanic activity.
Wind circulation.
Good. Air and water circulation. So both of them are affecting climate. Awesome. What do we call this line here? So let's say this is a globe and that line, imaginary line. Thank you. We know as you go north of the equator, it's colder, right? And then topography or geography, really in general. Where you are and the shape of the land, that's what topography is. So if you don't know the definition, just write it down. Also affect climate. The shape of the land. All right, so if you look at Earth's climate over a long period of time, so we're looking at the history of Earth's climate, just like in the previous slide, it's altered by these things. What are they? Let's repeat them. Solar activities. What else? What kind of emissions? Look at it right here. So because we're talking about early, right? Volcanoes created our climate. We used to not have sulfur oxides, nitrous oxides until volcanoes eruption. We got heavier levels. The sun, movement of what? What do we call this right here? Pangea went from here to here to here. So good. Continent shifting. And then the impact of some things that come out of the atmosphere called meteors. Look at the pictures, guys. But when they look at climate over the last, about 1 million years, it says that we measure our Earth's climate between ice age and the periods that are not ice age. So they call them interglacial periods, which is in between ice age, or glacial, which is our ice age. So a lot of scientists, when global warming started, said it was Earth's way of kind of preparing for an ice age. So if the ice age came and we were warmer, we wouldn't have it. That's a big topic of conversation. This is what our Earth's climate or temperature, let's be more specific because we're not talking about precipitation, has looked like over in history. And at the end of the day, if you looked at these graphs, and that's something you're going to have to do on this test is interpret graphs, you see a lot of fluctuating in the past, periods of warming, periods of cooling, periods of warming, periods of cooling. But when you look at the most recent data, what do you see happening? Overall, it's going up, okay? And we're going to talk a lot about this increase and what's causing it, okay? Yes. Yep. So how do we know about the history of Earth's climate? Who could give me some answers looking at pictures? Fossils. We always going to look at radioactive dating or carbon dating and look at fossils and remains of organisms, specifically plankton, insects, and feces of bats. What else do we look at? Okay, I'll take it. It's really in the glaciers in the North Pole, right? So they get these cores of ice, and if you want to really find out information about what goes on, you only have to know that we look at this to collect data. You don't have to know how the data is collected. And we also look at what? Yes, data. We look at temperatures that we have actually recorded accurately since around the mid-1800s, and we look at those patterns. And again, look at the fluctuating, increase, decrease, increase, decrease. There's periods where it drops significantly, but in the last couple of, I would say anywhere between 1950 up, there's just been an overall increase in our climate or our temperatures of our climate. So as you mentioned in the first slide, greenhouse gases are responsible for keeping Earth what we call habitable, okay? Without greenhouse gases, Earth would actually be too cold. We call this the greenhouse effect, and I'm going to go over this process right now with you, so you're going to do some extra writing on this slide and some coloring, so bear with me, okay? The sun. Okay, so UV rays come down. So the sun, and I'm going to put it in the image, and then we're going to write the text. The sun produces UV rays. Sun produces UV rays that come down to Earth. And that would be, since I'm writing this in blue, I'm going to take this and I'm going to make a blue line right here. And here are my UV rays coming from the sun, yes? What happens to these rays if you look at this diagram? So UV rays come down to Earth. They're reflected where? As what? Okay, so when UV rays hit Earth, heat rays, which are called, anybody know what heat rays from the sun are called? They're called infrared rays. Re-radiate. Okay, and then if we're going to label which are re-radiating, we're going to use this one right here. So I'm going to get my pen and I'm going to get red. And here are my infrared rays re-radiating out to space. However, some of these rays, and I'm going to move this down right here. Some of these rays come up as infrared because my infrared rays are red, but then they get pushed back down to Earth, warming Earth, and this is caused by greenhouse gases. In this case, this greenhouse gas is water in this diagram. Water is a greenhouse gas, and when it's in the atmosphere, in our troposphere, it will trap infrared rays and push them back down to Earth, warming Earth, which is what's called global warming. Now keep in mind, this has to happen. If not, we couldn't live on Earth. It would be too cold. Our problem lies in the fact that we've added gases to our troposphere that shouldn't be there in excess, which is causing more and more of these rays to come back down to Earth, which is causing excessive warming. So what are these greenhouse gases? And I want to tell you right now, these bubbles with numbers, you don't have to know them. So go ahead and take your colors and color in the numbers because you don't have to know these, okay? Who can name me some greenhouse gases? H2O, good. We just said it, right? Argon is not a greenhouse gas. It's just a heavy component of our... Good. Carbon dioxide is one, right here. What else? We've named these a couple of times. No, sulfur is actually not a greenhouse gas. It's heavily emitted during the burning of fossil fuels, but good. Nitrogen is a greenhouse gas. Huh? Methane, good job. Nope. The rest is a little hard. CFCs, believe it or not, are greenhouse gases, and ozone is a greenhouse gas. So remember that ozone in the stratosphere is great. In the troposphere, it leads to two problems. It leads to smog, and it also is a contribute to trapping heat and global warming. I'll go back. So, okay, keep in mind, stay with me because I'm going to ask you a lot of important questions here. Since the Industrial Revolution, okay, we have emitted excess amounts of carbon dioxide, methane, and nitrous oxide. If you look at your textbook, the only greenhouse gases mentioned in your textbook are these three. I just gave you an entire list of gases that are going to show up on the AP exam, but your textbook only references these. And the reason your textbook references these is because we call these the greenhouse gases that we are most concerned with because we have increased their concentrations in the troposphere because of these things. So what are we doing that's causing the increase of these gases in the troposphere? What? Deforestation. What else? burning fossil fuels. What else? Farming or agricultural practices. And what I like to call, which you're going to learn in our next unit, industrialized farming. Because farming has been around since forever, but it's the industry type farming that has caused excess of emissions. So now here are the types of questions you're going to see on the test. How can you tell me, or who could tell me a way that carbon dioxide is linked to agriculture or industrialized agriculture? For starters, we're going to say fossil fuel powered machines, right, produce carbon dioxide. And by machines, I mean plow, planes that fly to spray fertilizers, tractors, right? Fertilizer spraying machines, irrigation systems, all require fossil fuels to power, okay? That's going to produce excess carbon dioxide. What else? How do we get agricultural lands? And when you cut down forests, what happens to carbon dioxide? No, not. So I asked this question because carbon dioxide does not increase when we cut down forests. What happens to carbon dioxide when we cut down forests? It doesn't get absorbed at the same rate it used to. You cut down the forest, you're cutting down the absorbers of carbon dioxide. So although carbon dioxide levels won't increase, CO2, less absorption when you cut down forests. And we cut down forests in order to grow crops, okay? As somebody mentioned when I paused the video, nitrous oxides are linked to fertilizers, which is linked to agriculture, so that's going to contribute here. Anybody know the link to methane and agriculture? Good. Cows, when they flatulate, which means expel gases, they release methane. How else is methane released? That has nothing to do with agriculture, that you've learned already in this class. How else is methane released that has nothing to do with agriculture, but it's making an excess amount of methane in the atmosphere? And it's linked to climate change. Not glaciers, but good. Permafrost melting releases methane, okay? Burning of fossil fuels releases nitrous oxides and carbon dioxide. So you want to know these associations, okay? So we call carbon dioxide the #1 greenhouse gas of concern. And there's 2 reasons why. Why do you think? Think about when we study levels of gases in the troposphere. Good. It's the most abundant of that 1%, right? Because we know 70 is nitrogen, 20 is oxygen, but then you've got argon and carbon dioxide and other greenhouse gases. So carbon dioxide is the most concentrated in our troposphere, and it's also persistent. Anybody know what persistence means in terms of gases in the atmosphere? Good. They do not react or break down easily, so they kind of linger there for a long time. So once you produce carbon dioxide, it's just going to hang out in the troposphere for long periods of time, causing more warming. So now we've got this graph, okay? And for a long time, you only talked about carbon dioxide, methane, and nitrous oxide. Carbon dioxide being the #1 greenhouse gas of concern, but now we have to look at gases' potential to trap heat. So they have heat trapping potential. And I'm going to give you the order. Okay, let me change this to red. So the #1 trapper of heat, believe it or not, is water. Water traps like 100,000 times more heat than any other greenhouse gas. So if water's in the troposphere, it's going to re-radiate a whole bunch of infrared rays back down to Earth. And I may be exaggerating with 100,000, but it's a lot. Second, we're going to say are our hydrocarbons. Third is nitrous oxide. Fourth is methane. And fifth is carbon dioxide. Carbon dioxide traps tiny amounts of infrared rays, but there's so much of it that it's still something we're concerned with.